Alright, so today I will be talking about factorials and permutations. So I like to start off with a concrete example and then move into more abstract. So let's start with the problem. Students leaving the classroom. There are 30 students in a classroom, and one by one all students get up to leave. How many different ways can this occur? So if you think of it, you might say, alright, when the first student leaves, there's 30 options for that student to leave. Now one's gone, and you have 29 options for the next student, and then 28, and then 27, all the way down to 1. And so you would get that there are 30 times 29 times 28 times 27, all the way down to 1 different options that of students leaving this classroom. And we are going to shorthand that with 30 exclamation point, which is read as 30 factorial. So now that we have kind of idea of what factorial is, let's give a definition to factorial. When n is a positive integer, we define n factorial as follows. N factorial is equal to n times n minus 1 times n minus 2, all the way down to 3 times 2 times 1. And by convention, we have 0 factorial equal to 1. And we could also define this recursively as n factorial is equal to n times n minus 1 factorial. And let's now move into permutations. So I'm going to modify the previous problem. So 30 students are in a classroom, one by one. Only 5 students leave this time. How many different ways can this occur? So, like the previous problem, we have 30 options for the first one, 29 for the second, 28 for the third, 27 for the fourth, 26 for the fifth. And you might see that this is related to factorials, and we could actually define that as 30 factorial over 25 factorial. And I am going to shorthand this P35. So you are having 30 objects, and you're doing a permutation of 5 of them. So now let's give a proper definition to permutations. So for non-negative integers m and n with m greater than or equal to n greater than or equal to 0, define Pmn by Pmn is equal to m factorial over m minus n factorial. So that is equal to m times m minus 1 times all the way to m minus n plus 1. So it's like factorials, but you're cutting off after the nth number. So now let's look at some practice problems. A group of 9 students holds elections to decide a class president, vice president, and treasurer. How many different outcomes are possible? So if you look at this, we have 9 students and 3 positions. So you aren't going to use factorials here, it's more likely you'll use permutations. And what I like to do is I like to reduce this down to a problem we already know. So think of 9 students and 3 are leaving the classroom. And the first one who leaves is president, second is vice president, and third is treasurer. And we know how to solve this problem already. It's permuting 9 objects in 3 ways. So P93 is the answer to this practice problem. Alright, let's look at another one. How many ways are there to arrange n distinct objects? Now this problem is more abstract, and when you think of arranging objects, how might you do it? Think of reducing it down to students leaving the classroom again. And since we're arranging them in any order, and we're going to arrange all of them, think of it as n students where all of them leave the classroom. And so the order that we do can be thought of in order of students leaving the classroom. And so there's n factorial ways that this occurs. And I just want to leave off with one note that some of you might have thought of when looking at this problem, saying, can I do permutations here, like permuting n objects in n ways? And just to answer that, yes, n factorial is equal to permuting n objects in n ways, because By definition, that is n factorial over n minus n factorial, which is n factorial over 0 factorial, which is n factorial over 1, which is n factorial. So yes, you could just think of these all as permutations. Alright, thanks for watching.